Snake venom milker, a gob where you walk up to a creature capable of killing you within minutes, pick it up with your bare hands, and wait for it to bite. Not by accident, on purpose. And you don't do this once for a rush of adrenaline, you do it hundreds of times a week for years because it's your job. It sounds like a punishment invented by the Greek gods for someone who really annoyed them. In reality, it's a real profession that still exists today, and without it, far more people would die every year from snake bites than already do. It's worth starting with what humanity did about snake bites before anyone figured out how to turn venom into medicine, and the honest answer is almost everything except what actually worked. People pressed red-hot iron to the wound. They sucked the venom out with their mouths, risking infection through any crack in their gums. They drank alcohol by the barrel, not because it neutralized the toxin, but because it made a person stop caring that they were dying. They wore amulets made of skin-ski on the logic that like cures like. The most systematic attempt to build actual immunity came from Mithridates VI, king of Pontus, around the 1st century BCE. He reportedly took small daily doses of various poisons, hoping his body would adapt so thoroughly that even the most talented court poisoner couldn't touch him. According to legend, when he finally tried to end his own life after losing to Rome, the poison simply didn't work, and he had to ask a guard to run him through with a sword instead. The principle wasn't stupid, it just needed 2 more millennia, a proper laboratory, and a Frenchman to become real medicine. That breakthrough came at the end of the 19th century, courtesy of Albert Calmette, a French bacteriologist and student of Pasteur, who was sent to work in French Indochina, modern-day Vietnam, where cobra bites were killing people on a scale serious enough to worry the colonial administration. Calmette applied a principle vaccine researchers already understood. Inject an organism with a very small, non-lethal dose of a toxin, and its immune system learns to manufacture antibodies against it. He started injecting horses with gradually increasing doses of snake venom. A horse, being large and sturdy, tolerated this without much trouble, and in exchange, its blood accumulated antibodies tuned specifically to that toxin. Draw the blood, separate the plasma, purify it, and you get a serum that, injected in a bitten person, hands their immune system a cheat sheet for recognizing and neutralizing the venom before it can shut down the nervous system or turn the blood to jelly. In 1896, Calmette released the world's first industrially produced antivenom. The core method hasn't changed much since. Horses and sheep are still the main production engine, only now instead of 1 French lab, there are dozens of venom farms doing this work worldwide, from Costa Rica's Clodomiro Picado to reptile parks in Australia and Kentucky. But before you can inject a horse with venom, you first have to get the venom from somewhere. That's where the milker comes in, the person whose entire job consists of regularly, by hand, extracting venom from live venomous snakes without killing them, because a dead snake produces nothing further. The classic method looks almost theatrical. The snake is gripped firmly behind the head to control the jaw, then brought to the edge of a glass or rubber membrane stretched over a collection vessel. Provoked by the pressure, the snake bites. The reflex fires even when the animal is clearly more annoyed by the whole procedure than actually hungry, and the venom glands empty through the membrane into the container below. A single king cobra can yield several hundred milligrams in one session. A rattlesnake gives less, but more frequently. Some modern facilities have partially automated the process using a mild electric current to stimulate the glands without a literal bite, which produces a more predictable yield and lets handlers immediately assess the animal's condition. Even so, the manual method is still standard practice in most of the world, simply because nothing beats a trained pair of hands for reading a snake's mood in real time. The trouble is that no snake ever signed a contract for this arrangement, and none of them experience milking as anything other than an attack. Their reflexes are fast, their venom is entirely real, and the gap between successful session and trip to the emergency room is a few centimeters and a fraction of a second of inattention. This is why venom milkers carry one of the highest occupational injury rates of any profession that exists, higher by some estimates than miners or bomb disposal technicians, if you're measuring specifically by direct exposure to a lethal hazard during a routine shift. The best-known name in the field is Bill Hast, who ran the Miami Serpentarium starting in 1947 and, over more than 50 years on the job, extracted venom an estimated 2 million times. He was bitten, by his own official count, 172 times, including bites from species like the mamba and the taipan, whose venom typically kills an untreated person before nightfall. Hast survived every single one, and not by luck, but because, echoing Mithridates almost 2,000 years later, he deliberately injected himself with small, escalating doses of venom from multiple species for decades, gradually building genuine immunity. Eventually, his blood itself became a resource. When a snakebite victim arrived in critical condition and standard antivenom wasn't working fast enough, doctors sometimes used Hast's own plasma as an emergency measure, since it already carried a library of antibodies most people would never have. He turned himself into a walking laboratory, and worth noting, he died at 90 of ordinary old age, not a snakebite, which for someone in his line of work counts as something close to an achievement. The tradition didn't end with him either. In recent years, an American named Tim Friede made headlines for spending nearly 2 decades self-injecting escalating doses of venom from more than a dozen species, driven by the same logic Hast and Mithridates had already tested, that a human immune system, pushed carefully and repeatedly, can be taught to survive almost anything, one dose at a time. Here the obvious question comes up. Why not just synthesize venom artificially and skip the live animals and the human risk entirely? The uncomfortable answer is that in over a century, nobody has figured out how to reliably reproduce the complex protein cocktail of snake venom. Every species, sometimes even different populations of the same species from different regions, carries its own unique blend of toxins, and antivenom made against an Indian cobra can turn out to be nearly useless against a cobra from another continent entirely. Which means antivenom production, even in the 21st century, still runs on live animals at both ends of the chain, the snake on one end, the horse or sheep on the other, with a person holding tweezers and a membrane standing in between. And this is where the story turns from impressive to genuinely grim. Not the heroics, but the economics. Antivenom is expensive to make, slow to produce, and, compared to most pharmaceuticals, not particularly profitable because its main market sits in some of the poorest regions on Earth, rural Africa, South and Southeast Asia, where snake bites kill an estimated 138,000 people a year, according to the World Health Organization, and leave far more permanently disabled. Several major pharmaceutical companies have quietly discontinued specific antivenoms over the years, simply because they weren't commercially worthwhile, and most infamously in 2014 when Sanofi stopped producing Fav Afrique, one of the few serums effective against multiple African species, leaving hospitals across the continent holding a shrinking stockpile of a drug nobody else was making. The result is a strange, uncomfortable picture, a technology invented before our great-grandparents were born, capable of saving nearly anyone bitten in time, simply not reaching the people who need it most, not for lack of science, but for lack of money in the right place. Against that backdrop, the venom milker looks like the last hands-on link in an old-fashioned chain that still, improbably, holds up a piece of global medicine. Not a robot, not an automated production line, but one specific person who walks into the reptile house every morning, pulls out the next cobra or viper, pins the head, and waits for the bite, knowing exactly what happens if their grip slips a half second too early or too late. That person doesn't save anyone directly in the moment of doing the work. They just fill a vial with a fluid that will travel, months later, through horses and labs and shipping routes and end up in a syringe in some rural clinic thousands of miles away, saving somebody whose name the milker will never learn, which is the most accurate definition of quiet heroism there is, a job description that boils down to regularly risking your life for a stranger who doesn't even know you exist.